Today, we're going to talk about radian and degree measure. When we've been working with triangles and working with circles, we've been talking about 360 degrees or 45 degrees, 90 degrees. We've been talking about a degree measure. Here in trigonometry, we're going to move into radian measure. A degree measures an angle by how far something is tilted. Okay, so if we have something like that, here is our degrees. That is what we measure, is how far it is up like that. Where a radian measures the distance traveled by the arc length. So if this is our measure, and this looks like 80, 75, 80 degrees here, our radian measure would measure this out here, the distance traveled, okay, over the radius. That is a radian measure. So if you took this red part right here and stretched it out, that is going to be our radian measure. So today we're going to be working on converting. If we can convert, if we have degrees and we want to go to radians, what we need to do is multiply the degrees by pi over 180. So if we have the degrees, and I'm going to do some examples here in a minute. If we have a radian and we're going to convert the radian to degrees, we're going to multiply that by 180 over pi. One of the things that we can look at here, if we have degrees, we're going to put the degrees in the denominator to cancel them out, and we're going to be left with pi, which is radians. If we have something in radians, it is in pi, we want to cancel out the pi, so the pi then goes in the denominator. Okay? Remember, the top, or your numerator of your multiplier, is the unit we're converting to. We're converting to radians, we have pi. We're converting to degrees, we have the 180 degrees. So let's look at some examples down here. If I am going to multiply, and I want this to be seen. This right here, radians must always be in pi form. Okay, they must always be in the pi form. Degrees are going to be in the decimal form. Right? So let's look at this here. So if I have 90 degrees, I want to convert that to radians. So here is the degrees. I'm going to go to radians. I'm going to multiply 90 by pi over 180. Now, in our calculator, we don't want to say 90 pi over 180. If we do that in our calculator, it's going to give us a decimal. So what we're going to do is we can do it this way, 90 pi over 180. And then we can go ahead and simplify it. And this is going to be pi over 2. Because 90 divided by 180 is pi over 2. Pi over 2 is a huge one. You're going to see 90 degrees, pi over 2. All right? So another thing you can do in a calculator, if you're not sure what it is, put 90 divided by 180, which is 0.5 or 1/2. We want to always put that in a decimal, so 1/2, and then just put the pi in the numerator. Pi times 1 over 2. Let's look at another example. Down here, we have 7 pi over 6. We're converting that to degrees. So we have 7 pi over 6. I'm going to degrees, so I'm going to put 180 degrees over pi. I'm going to degrees, that's going to be in my numerator. You can see here the pi's are going to cancel, and if you want to do it in your calculator, you're going to have 7 times 180 divided by 6. And we have, if you can see that, 210. So that will be 210 degrees. So these are examples when you are converting from radians to degrees and from degrees to radians. Let's do these last two examples here. 200 degrees to radians. So I'm going to say 200 times pi over 180. Pi over 180 is what I multiply by when I'm going to radians. Radians has my pi in the numerator. So one thing you can do over here, I can say 200 divided by 180. And then I'm going to convert that back to a fraction, 10 over 9. So over here, this would be 10, and I have to have my pi, 10 pi over 9. That would be how to convert those. 5 pi over 4. We're going to go to degrees. So I'm going to multiply that by 180 over pi. My pi's are going to cancel. I can say 5 times 180 divided by 4. 220, whoop. Very hard to see on here, I'm sorry. 225 degrees. So that is going from degrees to radians and radians to degrees. There are ones on the back for you to do, okay, if you want to do that. I'm not going to ask to see that. Today, your assignment, you're going to be working on the special 30, 60, 90 triangles. Those are very special and very important for you to work on for what we're going to do tomorrow in the unit circle. We talked about yesterday coterminal angles. So if we have a degrees, there is 360 degrees in a circle. So if we want to find a coterminal angle and we're in degrees, we can add or subtract 360 degrees. Well, it is going to be between 0 and 2 pi if we're talking about radians. So in a circle, there are 0 to 360 degrees in a circle, and there is 0 to 2 pi in radians. Okay, and that is in a circle. So I'm going to draw a circle here. If this is my 0, okay, up here, this is going to be, we saw this was pi over 2. 90 degrees on the opposite side, we did that, and that was pi over 2. So if I add another pi over 2, 180 degrees is going to be pi. Another pi over 2 is going to be 3 pi over 2. And when I go all the way back over here, this is 2 pi. So is there 360 degrees in a circle? There are 2 pi radians in a circle. So if we want to do any of these to find coterminal angles, what we are going to do is we're going to add 2 pi. So negative 7 pi over 8. And I'm going to add 2 pi. I have to get a common denominator. So this is 7 pi over 8 plus 16 pi. Oops, this was negative. Over 8. Negative 16 pi over 8 is the same thing as 2 pi. So a coterminal angle would be negative 7 plus 16, 9 pi over 8. And there is a coterminal angle. So adding and subtracting 2 pi when we're in radians finds our coterminal angles. I hope this helps. I'll be on here between 10 and 11 and 2 and 3 if you have any questions. Have a great day.